what we're going to be doing is we are going to be creating an NFC tag programmer for the purpose of resetting the NFC tags that come with the Da Vinci Mini spools, or to program these paper tags. The reason that one would want to do this is many times if you have a misprint or you have a misfeed, you have a lot of filament left over, but the tag itself reads as that filament being used. So if you're like me, you have a lot of rolls of tags that are a lot of rolls of filament that when you put them on the printer, it shows them as being empty, even though there's still probably a quarter of the filament left. Additionally, you could use these for third-party filaments. For the purpose of this video, what I'm doing is I am using it to finish out the filament that I've already purchased, but it will work for either one. Now, as I talked about, you can reset the tags that come with the rolls. However, there is a problem because there is a DRM protection in the Mini, and it actually stores 100 UIDs, basically the unique identifier for these tags, on its system. So once you use a tag, even if you reset it, it is going to give you an error until it has had at least 100 other tags in there that basically pushes this one out of its memory. So why would you want to reset these tags? Well, if you have a group of people that use basically these minis, essentially you can trade tags with them and give them the reset one, and they can give you their old tag and you can reset it and use it on your machine fine. You just can't reuse tags that you've used until you cycle through 100 of them, which is the reason why a lot of us go with the paper tags, because you can get these paper tags off of eBay or Amazon pretty cheap. Essentially getting, like 100 tags for 20 bucks. And basically you program these, you throw them away, it's not really that much of an investment. So the first thing that you're going to need to do is source parts. I start with the Arduino Nano. It's cheap. You can get them off eBay or Amazon. And this will actually work also with the counterfeit ones you see on eBay. So you can essentially get you a $4 Arduino Nano off eBay and it works fine. There's a couple different ways you can go as far as the NFC tag reader. This one is, it's very specific. You have to get the PN532 NFC tag read write. It is specifically for the tags that are recognized by the Mini. It's the way the programming's written. I did not write the program, and I'll put all the credits when we get to the actual programming phase. But you can go with this pre-built NFC tag reader, it's nice in the fact that it's relatively easy. You can set it up on a project board like I've done here, or you can go with the different 532 tag of this style. With these, you have to solder the connectors on, and that's what I'm going to be doing today to make these work. This one is actually a little bit more powerful as far as it's got a little bit better range than this blue model, which is important because the paper tags tend to not like this one. I started out with this one. I was able to program a couple tags, but I got frustrated with the fact that you're constantly trying to find that sweet spot where the tag works on this thing. So I'm going to be building this one today in order to avoid that. Again, these are PN532 tags. I'll put a link in the description to kind of show some examples of those. They're easily sourced off eBay. And honestly, this whole setup should cost you about $25 to build. So all I've got here is just the rig set up for me to solder and test everything out once I'm done with it. And once we get through with the soldering portion, we'll talk about how to wire this up with the Nano in order for it to work, which ports you have to go to. And it's really not that difficult. Honestly, this soldering is probably going to be the most difficult part of this whole evolution, mainly because I have shaky hands, as you can tell. So I will put the camera on the stand to mitigate that. All right, so all I'm doing now is I'm taking the tag and taking the assembly that comes with it. and basically putting this in here and then soldering it on. I like to go the opposite direction, mainly because you got your sensitive electronics over here. So if you're like me and have a little trouble holding your hand steady, it's a little bit more forgiving. So basically you'll take the tag, take the connectors, push them through the circuit board, and then you'll see the little nubs basically stick out here, and basically you're just going to put a drop of solder on each one of these nubs in order to hold it in place. And that's pretty much it. So I'm going to get this set up and then start soldering. And this is why we can. What I'm doing now is verifying the solder to the endpoint connections actually is a good connection. Because if it's not, then it won't work. Okay, so ugly solder job, but still it works well. All right, so now that these are soldered together, we are going to essentially duplicate what I did on this unit here and do it with this one. I'll put a diagram, or not really a diagram, but a connection point. Every point here has a number or a abbreviation, so it's relatively easy. The hardest part for me is I don't have the best vision to go along with my not having steady hands, so I have been known to put one over one, but still not too bad. So first, what I'm going to do is I'm going to put it on the test board, and I highly recommend doing one of these because it allows you to just test the circuit first, and then you can do something more permanent by soldering, or you can use these female to female connections that are listed in here, which work really well for something permanently. All right, so here we're showing the nano card. We'll be using certain plugs on this card. So to start out with, the red wire will be the 5-volt connection. The black wire will be on the ground. The green wire will be the D13 connection. Brown will be D12. Yellow will be D11. And orange will be D10. And I'll show you where these connect on the other board here in just a second. All right, so we'll start with the obvious one. The 5-volt connection from the nano board is going to connect to the VCC portion right here. So this one right here, that's your voltage. The ground connection, pretty obvious there. Ground goes to ground, abbreviated GND. So as we said before, our D13, which is the green wire, is going to go to SCK right here on the top. And make sure that you are looking at your board where that's connected to. All these connections just slide on and push on, nice and easy. Again, this is for temporary testing only. We can do more permanent connections once we test everything. D12, which is our brown wire, will go to the MISO, or the master in slave out. That's also abbreviated as MI on some other boards, but it's always going to be MI or MISO, master in slave out. And that connection just slides on right there. Similarly. All right, then our yellow D11 is going to go on the master out slave in. Also, in some other cards, just abbreviated as MO or MOSI in this particular instance. Again, that slides on nice and easy. And then our final one, which is D10, goes into our SS slot right there. So basically all 4 wires go nice and easy next to each other, and then that slides on just as so. So to recap, 5 volt goes to VCC, ground goes to ground, D13 goes to SEC, D12, which is the brown cable, goes to MISO, master in, slave out. D11, yellow cable, goes to master out, slave in, MOSI, also shown as MO. And finally, D10 goes to SS. And that is the completed circuit. So now we're going to transition over to the computer and get the software that we need and test this out. Now, there's a couple different options. As we see, you got the VCC and the ground over here. I went ahead and moved the VCC and ground back just to keep a nice little area for everything to go into. One last thing that we have to do is you have these limit switches down here. You want this measured for SPI. So you'll see, if I can get this in focus. Let's move this light around here, make it a little bit easier. It doesn't wash out. I apologize for the camera work. I actually have some really nice cameras and then have not messed with them for a while. So you've got, so you'll see SPI here. You want 0 and 1. So basically the switches should be in different positions. So there you see HSV, which is both off, which is what it comes as default. 12C, which is the first one on, second one off, and SPI, which is the first one off, second one on. So we're going to switch that switch position here. I'm going to put the phone down to do that real quick, and then I'll show you what it looks like afterwards. All right, so you can see right there, you have the top switch in the off position and the bottom switch to the right. So that is basically set up this tag for SPI. So this is what it looks like. You've got 13 going to SCK, 12 going to MISO, 11 going to MOSI, 10 going to SS, your 5 volt going to VCC, and your ground going to ground. And that is how that card is set up. So the first step is installing the driver for the Arduino.